First question up. Boom. We got there. 2 minutes and we're here. Whee! Class time not being used efficiently, anybody said? Ah, whatever. You gotta have fun. You gotta enjoy yourself. You know, all this, you must be totally focused and do all you can, blah, blah, blah. Who does that? Seriously. Really, you know? Alright, hope you're feeling happy. And see, now I'm gonna start to go quiet and give you time to answer the question. Yeah. Alright, write the missing numbers, get in those missing numbers, and I'll give you 15 seconds if you're not done already. You know, 15, 14, 13, comes after 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh yeah, it is my turn to work out the question. First you need to find the common difference every time. What number are you increasing by? And I look and I see that this is adding 45. Yes, I'm adding 45. So if I keep that pattern, I'll get 290, and then I gotta think a little bit more. If I add 45 to 290, woo, if I add 10, I get 300. So 335. And then for the first number, you had to go back. And if I take 45 from 155, I get oh, you know what you get? You get the pen is no longer capable of writing. I need to shift my screen. Sorry about that. Now back to the song, which probably doesn't go in time with the background music, which you are hearing, which I cannot hear. To hear it, I need headphones. I don't want to like jazz. My head is big enough, don't you think so? Do not dare say that, right? Okay, right. 100 and what I want, 150. No, not 150. No, 100, 110. Now I'm gonna check this one. 110 and 45 is 155. I think that I got it right. Did you get it right too? Ooh, yeah. Okay, cool, good. That was a quick one. Feel good. Let's do another one of these. Trust me, we gotta work really hard today to feel good, to feel happy, and then we're gonna do. Then we're gonna have to think real hard. We're gonna y'all. Yeah, it's gonna come. Right. Let's move on to next one. Yeah. 15 seconds. We'll work on 15. Let me see what you come up with. So I won't be too long. I will give you a chance to get your answer on the question. Oh, I wasn't counting the time, was I? 8, 7, 6, 5, 4, 3, 2, 1. So what do you have for me for here? What's going on this one? Let's see. Factors. What you want to put down here? Oh, whoa. That's from yesterday. We like so don't. That's from a long time ago. We like so don't want on that one. Helps see when you go clicking. Right. Okay. Let's get going back here. We're having a lot of like what malfunctions. It's like, you know, those wardrobe malfunctions. Think crazy things happen on a live show. But hey, it's all good. Right. The factors of an even number are always even. Really? First thing is, what is the word factor? The factors are the numbers that you multiply together that you can multiply to get your number. So factors, for example, factors of 8, numbers that I can multiply to get 8. Two factor pairs is what I'm describing better, I suppose. Yeah, 1 times 8 will give me 8. So 1 is a factor because 8 is in the 1 times table, so 1 goes into 8. 2 and 4 are factors of 8 as well. So that's the idea of factors. Now, all these numbers are even, so you want to use that as your reason. That's why you're going to say that this is a true statement. Right. Let's deal with that. An even number. What's an even number? An even number is a number in the 2 times tables. So an even number is a number with a that 2 has to be a factor. But hang on. Wait a minute. Let's just check this. If I choose the number 10, I can get 10 by using the factors 2 and 5. Yeah. Or actually, hang on. Let's just wait a minute. Wait a minute. Did you see what I just saw? If we go back to the 8, factor pair that gets 8 is 1 and 8. What kind of number is 1? Yeah, 1 is an odd number. Okay? So this is a, and I hope I'm showing you that there's lots of reasons you could have said, 2 times 5. 2 times 5 is equal to 10. That will be a good reason, because you're showing, and then you have to say that 5 is odd. Okay, we need to make that clear. And that's a reason to show that the factors of an even number are not always even. They're not. You know, every 1 is a factor of every number. So whether you're even or odd, you're going to have a factor that is odd, guaranteed. Did he get that? Yeah, did he get that? All right, good stuff, good stuff, good stuff, good stuff. Let's move on. Happy days, happy days. You know when I'm this happy, it's because we're gonna have a moment, aren't we? Right, let's do another quick, right, prime numbers. Look at that one, see what you come up with, por favor. You know, sort that out real quick, please, real quick, real quick. I'll give you a timer. I gotta start going down in my timer. Should I start counting? Should I start counting down? Okay, I'm gonna start counting down. Yeah, so like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, give me 5 seconds extra. Young people nowadays, always 5, 4, 3. Okay, right. So you would have circled 87 because it ends in a 7, and everybody knows if it ends in a 7, it has to be a prime number. Yeah. No, it doesn't work like that. It does not work like that. It's the 9. It's the 9. The 9. Gotta be the 89. Yeah, that's definitely prime. Yeah. But how do you know? Is it really that? I'm going to tell you, yes, 89 is the number. Which number is the prime number here? I'm taking you out. Forget, 89 is the number. Why? And we can answer that using these other questions. How do you know the others are not prime? Well, ends in 5. So in 5 times table. Yay, I'm very fit. I got that. Any number ending in 5 or 0 is in the 5 times tables. So 95 is in the 5 times tables. Okay, 5 is gonna go. I don't know how many times. Well, actually, I do. It's gonna be how many times? How many times am I gonna get 5 and 95? Going 4, 3, 5 seconds. 19, because 5 goes into 120 times. Knock off a 5, you get 95. Slick. Right, now 87. How do we know number ending 7? Come on, it had to be 87. It's not 87. Why? Because 8 plus 7 is equal to 15. 15 is a multiple of 3. So in 3 times tables. My doctor handwriting. Whoa, damn, I went too far on the screen. You got to see it there. That is the word tables. Honest, tables. Okay? Work with me. It's hard. I don't even have a normal pen. It's this digital thing and I'm writing on. Look at what I'm saying. Just now. My desk is getting cluttered. I need to clear up my workspace. I'm writing on plastic, It's not easy. It's not easy. This is challenging. It is challenging. See, gotta have that sorted. Okay, right. So any number. The second idea Any number with a digit sum. We call it the digit sum. If a number has a digit sum, that's in the 3 times tables, and digit sum because I added the digits. So 8 plus 7. That's the, so we call this the green digit sum. Digit sum. Okay? It's 2 separate words, by the way, and I'm writing them too close. Digits. Oh, damn. You see why I wrote them in close? This is hard. I told y'all this is hard to do. Right, the digit sum. So because the digit sum is a multiple of 3, that means the number is in the 3 times table. So these are a couple tests of divisibility, and you can use those to identify prime numbers. Really, really popular problem-solving technique there. So, right, we're all right. We're all right. Let's do another one. Let's do another one. Boom, boom. 10 seconds. Yeah, I'm watching you. I can. Yeah, it's a two-way camera. Slick. Yeah, two-way camera. Oh God, I'm joking. Well, actually, that shouldn't make a joke about that. You know, I can't see. The only thing I'm seeing is plastic in front of me. Okay, that's all I'm seeing. But I'm saying I'm watching you. Yes, I am. Yes, I am. Finish. Finish. I gotta watch the screen to see what's happening as well. Yeah. Okay, right. Let's deal with this. Okay. What makes a number an odd number? An odd number is a number that has number that ends in 1, 3, 5, 7, or 9. It ends in it. In other words, it's all about the ones digit. So if I write 371, it's odd. But have I saying then if I use that number, I'm just saying I can say that is that a reason to say this is true? That the statement all the digits in an odd number are odd. I have an odd number 3, I have an odd number 7, I have an odd number 1. So does that work? Well, hang on. No, to be odd, it's only the ones digit that has to be odd. So if I now make a change and I was to say that 4, yes, that's an even number. 6, another even number. Come on, let me properly. 2, 4, 6, 8. Whoa, all those are even numbers. At the moment, I have an even number, 2,468. But if I put in a 7 there, all of a sudden I get an odd number. Only to be an odd number, only the ones or the units digit, only the ones digit must be odd. And I should put an is there. Right. Now, in terms of reason, just writing down 2,460, 2,000, what am I saying? 24,687 is odd. Just writing that down. 24,687 is odd. And then putting something like, but 2, 4, 6, and 8 are even. Even digits. Doctor handwriting is really bad today. That would be satisfactory as a reason. So that's enough for a reason. And yeah, you're getting the idea. Okay, right. Off you go. And I'll paste the timing reasonably okay. Timing. Started off with time. You like it? Ooh la 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 la. I'll zip it. I'm gonna start doing my work. You doing yours? Yeah. Okay. Okay, so what I'm going to do, because I want to make sure I get the timing right for these. Yeah, about 90 seconds. It should be fine. You're fine. You're okay. You're ready to go. Let's see what's happening here. And let me get my timer as well. Okay, so we're gonna start. Let's start talking about it. You have an answer. You're waiting on me. You have an answer, and you're waiting on me. If you don't have an answer as yet, and you're not waiting on me, then use the power of the pause. Okay, use the power of the pause. And you know what? I just realized. Wait a minute. My music. Oh, I forgot my music, didn't I? Got to put the music on. How do I do that? Right. Oh, sorry. My bad. We should all the dramatic. So you've been working in silence. Come on, you want to hear the drama? Yeah, this is what we're talking about. Okay. Yeah. Yesterday was the microphone. Today was the music. My goodness. Let's do this thing. What time is it? What time is it? The key language you were looking for this one is exactly. It's a 40-minute lesson. 40 minutes. Whoa, that's not working. What's happening there? Because I had the rubber on. I don't want to rub off anything. It's 40 minutes. We know the start time 11:50, and exactly in the middle of the lesson, the bird flew in. So exactly in the middle. What's the middle of 40 minutes? A lesson is going 40 minutes. We want halfway point. So the first thing you wanted was half of 40. And what's half of 40? That's right, 20 minutes. So that's what you're thinking about. It's 20 minutes in to the lesson, this bird flies in. And if it's 20 minutes in, the lesson started at 11:50. Remember, you have the power. If this is your aha moment, you have the power of the pause to pause the video. Don't worry, you can pause live and then get your answer and then compare it against mine. But power of pause means that what I mean, power of pause means what it means. I started at 11:50. I'm adding 20 minutes on, 10 minutes, and this is where I'll scale it up quickly. 10 minutes will get me to 12 midday, okay, and then I'm adding 10, and then I add another 10 minutes, and it's gonna get me to 12:10, right after lunch, right after noon. So 12:10, is that AM or PM? 12:10 during the day, AM or PM? It's PM. That's right. So your answer for this question, 12:10 PM. 12:10 PM. Okay, feeling good. Yeah. Right. Yeah, you like it? Okay, good. Let's move on. Next question. Football. Oh yeah. I'm playing my team wins. What do you expect? You know, see how many goals did we score? Think about that. How many goals did we score? Because so that's what you're thinking about now. And I'm writing timer there. I'm supposed to be writing it in Google to search. That's what we're doing. All right. I just want to balance the time right as much as possible today. So you're working on this you got maybe you have an answer already. Do you have an answer already? Okay, yeah. I'll give you about 30 seconds again. I'll start highlighting the important information, which is not. Okay, you got something? Okay, here's my logic on this. Yeah, we've had some time to work on this. My logic, okay, there's 9 goals that were scored. And we're thinking about a football match, so we're thinking, what could have been the score? If it's 9 goals, could have been like 9-0, yeah? Could have been 9-0. Or it could be something else. For I was checking the music. I'm a bit funny today, because I'm thinking there was so much time yesterday with you couldn't hear me. Oh my goodness. Right, so I'm gonna write the numbers down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. I got it to fit. Yeah, fit. Right. And then I'm thinking, okay, right. If it was 9, it could have been. And then I'll put 0. It could have been 9-0. But 9-0, if the score was 9-0, the difference, I didn't win by 3 games, so that's not good. So then the next thing I'll think about the other 2 numbers, 8 and 1, and I'll think, well, okay, 8-1. So you see, I'm taking a systematic approach, biggest takeaway, the smallest, and I'm going to work my way down until I have a situation. I mean, in each situation, you're seeing what's happening. The amount of goals scored are 9 with this strategy, and I'm just seeing, well, did I win by 3? If it's an 8-1 game, I won by 7. That's no good. So now I go in and now I'm tracking 2 and 7. If I played the game and my team won 7-2, how much did I win by? 7 take away 2, which is 5. That's no good. I win the game by 3. Now the next one I go to is 3 and 6. And I think, okay, if it was 6-3, I won the game 6-3. 6 take away 3 is 3, and that's it. We got the answer. How many goals did my team score? Dwayne's team, yeah, Mr. D is Dwayne. My team scored 6 goals. The answer, 6 goals. And look at that strategy, that pattern about we want 9 as the total, and you can just start coming in with the numbers. 9, 0, 8, 1, 7, 2, 6, 3, until you get the difference. The difference is the answer to a subtraction problem until you get the difference you want. In this case, 3 was what we wanted. So that's it, sorted. Let's go on. Let's go on to another. Oh, can't get on to another. My pen was being funny there. The digital pen controlling the screen. Right. Next question for you. Ooh, the magic square. I'm sure you've done these. These are really popular in the UK. Come on, you've done one of these before. What's R? I just want R. I don't want all the numbers. I just want R. See what you can come up with on that one. Let me get this timer thingamajigger up and running. I'll give you like 90 seconds. 1:30, 1 minute 30 in. Yeah, clock is running. Let's see what happens. Isn't this exciting? You like it? Yeah. After about 30 seconds or so, I'll put first like hints to get you moving forward on it. Okay. It's about making sure you know the rules of the magic square. So if you weren't sure what that word sum means, it's the answer you get when you add up the numbers. So that's what you're thinking about there. Whoa, okay. Got that sign. So you had about 90 seconds on this. And the idea is that, well, 36. That's the magic number in this magic square, because when I add up this column, I get 36. 10, 20, 30, 5 and 1 is 6, 36. That means and remember in the magic square, the key information is all the rows, all the columns, all the diagonals have to be equal to 36. The other idea you need to remember with a magic square when working with questions like these, with most of these diagrams, is you need 2 numbers to get the third. You need at least 2. Well, yeah, it's 3 numbers. We're working in rows, columns, diagonals of 3s. You have to have 2 of the numbers already to get the third. So what's the next number I can find? That means you can't find R because you only have 1 number in this row. You have no numbers in this column. So the row that you have 2 numbers in is the row with 10 and 14. So you're thinking I have 10 and 14, add them up, you get 24, and then you're thinking, what do I add to 24 to get 36? How much more to 36? And you could use your number line, 24. If I add 6, I'll get to 30. If I add another 6, I'll get to 36. 6 and 6, 12. So the number missing is 12. Now you still don't, in terms of, you don't have 2 numbers in this column to use to find R. The next strategy where I would go with this is I would think about the diagonal. I want to find this number up here. Because if I find this number on this in this row, then I'll be able to find R because I already have 15. So now I'm going on the diagonal and I'm thinking I have 23. I have 23. How much more to 36? And that's going to be easy. I don't have to do it all over again. You don't have to do it all over again because well, when you had 24, you needed to add 12 to get 36. So when it's 23, I'm going to have to add one more. In other words, visualizing it, I'm just thinking about it. I could write down, well, 23 was here. That means it's an additional 1 I need to add. So instead of 12, it's going to be 13. And you quickly check 10, 20, 30, 30 in turn adding the 10s, 6 and adding the 1, so that's 36. Now we can find R. And you have the moment there. Remember, you can, throughout my explanations as I'm going through, you can use the power of the pause. We can't talk with each other. You have got the chat as well. I can look at that and add some, you know, and that could feed into my thinking. But you want to pause me and work through it if you get your aha moment and you weren't successful before. Or maybe you're just ready waiting to do the dance because you did everything I've done up so far and you're thinking, I know what it is. And what is R? Well, we have two numbers, 15 and 13. We have two, we can find a third. That's the strategy. Have two, find a third. So game over when we do 15 plus 13. That gives me, I'm adding the 10s, 20. I'm adding the 1s, 8. Interesting strategy for addition. Do you do it like that? That's sort of how the brain works. So something to consider if you want to speed up your addition. 28, how much more to get to 36? If I start at 28 and I want to get to 36, 2 to 30, and then 6 more, I need to add on 8. So the value of R is going to be 8. The answer you're looking for, 8. And we can check it out. 15 and 8 is 23, 23 and 13 is 36. So the answer for R, unless I've made some crazy mistake, that's my disclaimer, is 8. And can I just make this point there? Not because I'm teacher and tutor and super, I am a bit smart, to be honest. In fairness, I am a bit smart, but I can make mistakes. So if you got something different, please say, you know, and yeah, and we can learn from each other. It is a two-way street. That's true. It is. It is. Okay, so we've looked at 3 of these. How you feeling? You feeling good? Let's go for a 4th one. Let's go for another. From Australia. This one was from Australia. Let's go to International Kangaroo. I think, is it the French that organized this? Probably, yeah. But you can do this competition here in the UK, right? I'll give you this was, oh wow, yeah, I'll give you 90 seconds. 90 seconds. We'll do 90 seconds on this. Yeah. Read carefully. That's the advice I'll give you. And I'll start highlighting key information if that helps. Cool. Okay. Strange not doing anything, but I gotta be quiet. Yeah. Gotta give you time to think, and that's important. But then, if you're thinking, and I'm not in a class to walk around and see what you're doing, it's like, what do I do? I'm just sitting down here. I'm not. Okay, yeah. You see, I don't want to just do. Do you love? Doing maths is fun. That's the thing. So I just want to get in and do the question. Okay, right. Mine's now. What you got? Yeah. All right. Let's do this thing. Now, all the digits have to be 1, 2, and 3. First, so I'll you know what? I'll just and we have this thing about there's a range. We say it's a range of numbers. It has to be bigger than 10. So I'll put that symbol. Familiar with that? That's my numbers have to be bigger than 10. My numbers have to be smaller than 32. The way we would represent this, I'll just throw this out to you in formal mathematics. We'll say let n, we'll say something like let n be the number oh, n be a number, and then I can say n. All the n's I'm thinking about are less than 32 and greater than 10. So you can combine your inequalities, your more than and your less than symbols. You can combine them. So we're thinking that's the range of numbers we're thinking. That's an add-on into the formal maths. You didn't need to do that for the question. I'm just throwing that in there so you can, I want to get you to the big stuff as soon as I can. Okay, but okay, right. So let's focus on this question. Your strategy. I'm making numbers. I know it has to be less than 32, smaller than 32, and I can use the digits 1, 2, and 3. So I'm just going to write all the numbers. That's the way I would do it. Okay, I got 1, I got 2, I got 3. Then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 should come to your mind. The rest don't count. And then in the 20s, 21, 22, 23. Because I can only use 1, 2, and 3. So nothing with 4, 5, 6, 7, 8. All those are gone, yeah? And then 31, and I'll write the number 32. So those are all digits. I was going up to 32, and then I have to make sure, have I followed the rules? Now, the first rule is that your number has to be less than 32. So can I count 32? Is 32 less than 32? No. So 32 gone. And then we also said the number has to be more than 10. So can I use 1? Can I use 2? Can I use 3? No. Now you're left with all the numbers that meet the criteria. These are all the numbers more than 10, less than 32, using the digits 1, 2, or 3. And yeah, we could have used the digits more than once. So how many numbers? The question wasn't to list the numbers. The question was, I didn't underline it, but that's important. How many numbers are there? Well, there's 1, 2, 3, 4, 5, 6, 7. Your answer to the question, 7. There's 7 numbers that use the digits 1, 2, and 3 that are bigger than 10, that are smaller than 32. That's what we're looking for. 7 numbers. Let's go to another. Let's go to another. Ooh, that's nice. That's different. What do you come up with for this one? What do you come up with for this one? Okay. Oh, clock. Clock. The clock. I'll start putting in. Should I start putting in some help? Yeah. I'll start putting in some help. Okay, what do you have? I started putting in some ideas. The first thing I did that I think you would have wanted to do is, it's nicer to write the fraction. You've got fractions, 1/10, 100, 1000. To write it using in numeric form as opposed to word form. And then you need to be thinking about place value. Place value and for decimals. And you have your hundreds, you have your tens, then you have your ones column. But what comes after? It comes the decimal point. And then you start thinking about all the fractions. We're working in powers of 10. And by powers of 10, remember, we had 1, 10, 100. And when we go for the decimal point, we just start, the first position in the decimal point is the tenths column. So if I put 0.2, I'm saying I have 2 tenths. Then the next position is the 100ths column. So if I was to put a digit here, I'm saying I have 1 out of 100, 2 out of 100, 3 out of 100, etc. And then finally, the third column is the thousands column. That's how your place value works. So in this case, I have 1/10, so that's 1. I have 1/100th, so that's another a 1 in the hundredths column. And then I have 2,000, sorry, 2,000s, so I have 2 in the thousands column. So write your answer as a decimal. That's your decimal there. Do I have any hundreds, tens, and ones? No. So that's a big fat 0. And then I have 1, 1, 2, 0.112. When we're talking about decimals, we call the digits individually. So don't be going and saying no 0.112. We don't do that. It is 0.112. In other words, it's 1/10 and 100th and 2,000ths. That's what it means. That's the answer you were looking for there. That's the answer you were looking for there. Let's go again. Let's go again. Another one. Another one. You're enjoying yourself. You're having fun. What about these? Are special. These are classics. Kind of thing you see on like a 11 plus or a 7 plus exam, isn't it? But and you see, the thing is, I mentioned that, you know, well, the reality is what we're doing here at Raymondson. When you're part of our maths club, we cover all that stuff. We go beyond that stuff because we're preparing you for the Olympiads, the Olympics. It's about the big competing against. You want to be the best, one of the best in the world. That's what we're talking about. So 11 plus, easy business. That's just part of the bigger picture that we're looking at. Okay, yeah, great. So you're working on this. I took so many time. I'm sorry. I'm sorry. Okay, right, looking at that. You know, we just had the SpaceX. We just had that a couple days ago. So T minus 7, 6, 5, 4, 3, 2, 1. We are go. We are go. Teacher is go. He's been let loose, and let's do this question. We're watching the pattern, and we'll do a strategy called balancing. We could do this because it's all addition. So, I have 6. I added a triangle, but a triangle is being added on the other side. So I'll say I'll cancel those out. I added another triangle, but there's another adding a triangle on the other side. So I'll cancel those out. I'll balance out. I can take those out. Think of it as if you had weights on a scale. You know, actually, this is what I'm trying to say. Look at what I'm trying to do here with the weights on a scale idea. Okay, balancing. Yeah, that's a scale. On the left-hand side, you got 2 triangles and a 6. On the right-hand side, you got 4 triangles. They're all being added together, yeah? So if it is that I take one triangle, the triangles they're the same values. If I take one triangle off on the left-hand side, the equal sign is in the middle there, then I could take a triangle off on the right-hand side. If I take another triangle on the left-hand side off, then I can take a triangle off on the right. That's the only way the scale is going to keep balancing. And then what are we left with? We're left with 6 on the left-hand side and 2 triangles on the right. What does that tell you? Each triangle has the same value. So if 2 triangles make 6, what's one triangle? Exactly. Your answer, triangle plus triangle is equal to 6. So triangle is equal to 3 because, hey, 3 plus 3 is what will give you 6. So the answer, the value of the triangle is 3. That's the answer. Oh boy, and hopefully that makes sense. This is the beginning of you doing this big, beautiful thing that scares people called algebra. You know, and you hopefully, yeah, you're thinking, oh yeah, I can do that, build that. That opens up a whole new world. Let's what we're looking at, 27. We got time for one more. We'll do one more. Oh, the rabbit. Yeah, let's do rabbit family hopper. We'll do this one to finish off. You know, I'm conscious of time. We got 3 minutes. Let me give you your time. Let me give you your time, right? Reading. You got your time. You got your time. Oh, I can. It has the music, and then I'm confusing things. You know, I read this and I experience this. I'm thinking about what we did today. I'm thinking, I believe I can fly. I believe I can touch the sky. I believe rabbits eat carrots and cabbages. Okay, I'm sorry. I'm sorry. Okay. Let's look at this. I was looking through. I have my list of questions. And I'm pulling them. And I was just thinking, there's some really exciting ones we haven't had a chance to do. Will be available, at the Mats Club. Get in touch, find out more about joining up, and you can experience those and more because it's awesome. Did you enjoy this one? I thought this is a nice one to finish off on, isn't it? Did you enjoy this one? Okay, right. So let's look at how we do this. I've highlighted some key information, and the thing is, every day, the rabbits, they're either eating 10 carrots or 2 cabbages. I've color coded them because it's either or. It's either you eat 10 carrots or you do 2 cabbages. Now, last week, we had this idea, and look, I put it in the same color because we're talking about each day and last week. So the first thing that comes to my mind, the first thing that clicks in my mind is how many days are in a week. And a week is 7 days. So we got to keep that in mind. A week is 7 days. The next bit I start thinking about, so I got this thing, okay, the week is 7 days. I asked myself now, well, how many, they ate 6 carrots. So I'm thinking, well, okay, 6 carrots. And we're doing 2 carrots. Oh, what am I doing, right? I mixed up the whole thing. It's not 6 carrots, it's 6 cabbages. Okay, right. So they ate 6 cabbages. Okay, the rabbit eats 6 cabbages, and we know that they're eating, I'll remove it from the highlighting. We know that every day, if they'd eat cabbages in a day, it's going to be 2 cabbages every day. So if I'm doing 2 cabbages one day, 2 cabbages another day, that's 2 days. I need to get up to 6, another 2. That means, in terms of cabbages, that was 3 days. 3 days, for 3 days, they ate cabbages. So for how many days in the week? The week is 7 days. 3 days you ate cabbages. How many days did you eat carrots? The carrots have to be 4 days. So the carrots, 4 days. 4 days, carrots. And it's game over now. How many carrots do you eat each day? If it's a day that you're eating carrots, how many carrots does the rabbit eat on that day? 10. That's what they said. If it's eating carrots on a day, it's 10 carrots. So 4 days of carrots, 4 days of carrots. That's going to be 10 plus 10 plus 10 plus 10. That's going to be 40 carrots. The answer to the question, 40. How many carrots did the family eat last week? 40 carrots. You got it? You got it? You had that? Then do the dance. Do the dance. And if you didn't have it, then hopefully you look at it as oh yeah, I get it now. I can do it. That's what it's about.